Let us discuss about Anova test. Anova is basically has been done two way. First one way classification. Second one, two way classification. In our syllabus, we actually explain about one way classifications. The one way classification, just I am going to the main topic. I have a question with different statistical data, basically different samples. On the basis of different sample investigating different observation of the samples, we have to calculate the F test according to the tabulated test. You have given some value according F test. You just comparison with your getting value, and you just check out either it is greater than or less than. This is the main funda. But before going to the Anova test, we first want to know that different knowledge about the variance. Anova is basically analysis of variance. Different variance, variance basically coming from standard deviations, and standard deviation is nothing with different getting different value or calculation or addition, then square something square row wise or column wise. In this way, coming from frequency also. So depending on these types of things, we just come to the main questions. That you just see that ABC, these are actually number of independent group, and those are data in a 3 column, and there must be 4 rows, and we added all the rows value below and right side also, and we're getting 220 addition all the values. Now Anova test based on this, basically this table that I write here, treatments, whatever it is, factors. It may be treatments, maybe the basis of this math, because the math is coming in June 22 in Ignou, and on this basis of this math we calculate the total source of variations, degree of freedom, sum of squares, mean, square, and F ratio. There is 5 column and 2 rows. We put those value after doing the math, and here you actually about to know that the K. What is K? K is total columns. That means ABC 3 columns, the main headline, main fields. Another total N is for 12 values is there. So in this way you calculate DFSS MS. And what is the main thing, that our H0, the average time to operates are equal to 5% significance, and that we should guess that in the math last that provided that the average time of all the operations are equal at 5% level, and HQ, what I actually, if it is not H0, then HQ is there, that is the average time of the operators are not equal to at 5% significance, either this or this. So the sample size, total sample size that is 12. Before I said that is n. Okay, now we're going to source of variance. That formula is total number of calculation to 20 that I calculate by 12 numbers, that is n. Then correction factor 220 square by 12, that is equal to 4033. Now we calculate SSTR. In this table SS, we want to calculate SSTR, the total sum of squares. We square all the values of 19, 17, 20 in this way minus the correction factor. In this way calculate 64.67. Next is summation of squares, that is total value of the first column, then it's squared, then total of the second column, then it's squares, plus total value of the third column, then it's squares by 4. 4, remember, this is very important, that 4 rows should be there, not column. Minus CF. In this way calculate the summation of square. Now square of summation error. What is the error then? Then SSTR minus SS, that is summation of squares. Because SSTR 64.67 and summation of error is this 64.67 minus 14, that is 24.5. Now putting all the values in the Anova table one by one. That is first 2 is TF, that is degree of freedom. 2, k minus 1, because k is 3 column is there, 3 minus 1, that is 12 minus 3, 9. That should be equal to the given tabulated value, you know, f 2, 9. That value is given here 4.26. So this is very common that 2 and 9 should be getted. Now SS, in SS, that is SSTR that I just find out here 14.17. Then SSER error 24.5, and in addition both of these should be 64.67. Now in MS what we do, that is SS by DF and also SSTR by error, that is 2.72. Now divide the two things, that is 20.085 divided by 2.72, that is 7.3 is very larger than tabulated value. So what I conclude in this way, conclusions, the calculated value of is greater than the tabulated value. So what assume that that is actually rejected H0, so HQ is selected.